everybody, Stephanie here for a hopefully an interesting tutorial. This is really something I'm creating on the side of the table. I think it's high time for me to put some content out there, more like tutorial-ish. So today what I'm going to do is introduce you to how to create an application to be used in the F256Jr or F256K. And essentially, when I'm saying creating an application, it's basically creating some, I'm not talking about a game or anything, although it could be, but personally, what I want to do is a cartridge file writer. So an application I can run, and you'll assign a file and you'll be able to program any sector in the flash. So when the microkernel boots, then it can get executed. Because typically you can either have a RAM cartridge or you can have a flash cartridge. But so far that the board is done and everything, but it's not been released yet because I didn't have a way to program them. So this is something I want to do, but along the way I would like to show you my process to get there. And it will give you a great head start, I suppose, for anybody who would like to do something like this. So I want to keep this is part one, because I want to keep these videos short, because most people seems to be interested to consume small chunks of information as opposed to 2 hours video. I understand. I, for one, I guess it's probably better that I don't spend 3 hours doing that. So again, it's still in the vein of not being super edited or anything like this. It's going to be pretty straightforward. So again, let's get into it, because I don't want to waste too much time trying to explain or anything why I'm doing this. So essentially, the way the system works right now, it's on both cases. When I talk about the Junior, I talk about the K. The differences between the two of them are so simple, so small that it's not even worth talking. Only the keyboard and the OPL3, that's about it, all right? So the way it works right now is that when you receive a unit, your unit, anybody else uses anybody else's unit, there is at its foundation a kernel that it's called microkernel. And the microkernel was created by this wonderful creator and designer, software designer, Gadget. And she has created a kernel that is called microkernel. And the microkernel is fairly advanced for the type of machine we have. There's threads, and there's like a IP stack in there. There's like that you can use with the Wi-Fi modules. There's a video about this. But essentially, what microkernel does, and there's super basic, but I'll come back later. But essentially, when you boot, microkernel starts, and what it does, it goes and start looking through the different memory section, and it starts like, I believe it starts with the cartridge, and to look for a signature at the beginning of a block. And that's the signature that says, hey, I'm an executable block, and here's the address it's going to boot, and here's the name of the application or the command you should put in BASIC or DOS, and I'll come back to DOS in a second. And basically just register it and say, hey, yeah, there it is. And then it goes and keep going through the different blocks to find the signatures and so on and so forth. So the microkernel just registers all the different blocks, and it starts with the cartridge, either RAM or flash, and then it goes into RAM, I believe, and I think it finishes by the flash itself, right? In the flash right now, if you have super basic, so if there's no cartridges, there's no application in RAM, it's just going to start with what's in the flash right now. And at the bottom of the flash, there's super basic, and then there's the documentation page, documentation application that just gives a lot of information about super basic. And you have an application called pexec, which is a PGZ, which is the Foenix PRG type file format for execution. And there's a PGX and there's a PGZ, and there's two kind of PGZs, the small z and the big Z, but that's in the header to describe either a 24-bit or 32-bit segmentation or program, and PGZ allows you to do multiple blocks at different location. PGX is just one block, like PRG in the C64, but just for 24-bit, if I recall. All right, so pexec is one of those applications that can execute a PGZ. So the process of creating an application or something that will run can be either a block that you will store in flash, either in the local flash in the system, like the application I want to do is the flasher, and the flasher I'd like to be an application or like a command, because it's at the end of the day, the name of the application will become a command name. So when you're in DOS or Super Basic, you get to type that name and it's going to execute it. And but I could create a PGZ and then release the PGZ and say, hey, run it. So either way, but one could decide to create like a game and then make a PGZ out of it. At that point, you don't need the header anymore. It's just PGZ. So both cases will work. So as far as I wanted to talk about DOS. So when Gadget created the application, the microkernel, she also created this DOS type application. So it's really like a shell. You can get out of Super Basic, go in the shell, do some things here and there, and then you can go back to Super Basic. So DOS itself is an application that works exactly the same way. So there's a header, there's the application, and when we call DOS in Super Basic. So you see, it's kind of interesting because when you call that name either in one or the other, then it's going to execute it, right? So this is the model I'm going to go with, which is essentially that I want to create a small software that will allow me to program, so assign a file name, a binary file name to a sector in the flash and program it. And I guess that part of that binary, you should have the same header that says, hey, this is a game, blah, 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 and so on and so forth, and you should execute it, more or less. So this is where we're going with this. So right now I'm working, like I said, I want to keep this as short as possible. I repeat myself, I know, but this is part one. And right now I'm just, we're not going to go too far with, we're not going to do anything with the computer in part one. Specifically for me to start, what I had to do, although I did that, I'm going to shut this down. I'm going to start, no, not this. Not this. I need my web browser. All right. Where's my web browser? Did I shut down my web browser? No. Where's my web browser? Oh, where's my web browser? What the? Because I closed it? Maybe. Yeah, that's it. Okay. So what I want to do, okay, so I said three things. I'm going to put the links in the description. Essentially, Gadget has a GitHub, and within our different repo, I'm going to say repo, it's a lot easier for me. There's one called F256Jr kernel DOS, right? So within that kernel DOS, there's the CC65, and we're going to talk about this in a minute. And there's also DOS, and there's a portion with some code about the kernel, but it's not the kernel source code, it's something else. It's probably a library to connect to the kernel. We're going to go in CC65, and here there's an example, and that's what the example I'm going to use. And I start using already. All right? So I'm going to put the links below. So the second thing you want, aside of having the code, is to get the application make for Windows. All right? I'm not going to go tell you how to do it and how to understand it. This is one of my pet peeve. these software that you need to install, but there's no installer. So you need to go and set up the path in the system variables to target where the application, the binary, the executable is. For me, it's a pain in the butt. I hate it so much. So I'm not going to tell you what to do. And by the way, what I'm talking about is about Windows. I'm sure you'll figure it out if you are on Linux. I think it's going to probably be a lot easier because you can do a git pull and it's going to be a lot easier. But fundamentally for Windows, install make the application, which is 3.81. You go in the system, you install the path in the variables, and Bob's your on call. Then you need to install CC65, which is a C compiler, and assembly language compiler and linker. It's used on so many different things. So Gadget used that for the example because I'm going to create the application in C. Why I want to do it in C? Because I don't have a lot of time. I'm very my capacity to develop C is very quick, and I'm very good at it. I mean, relatively good at it. I'm not like a cult member of how to do the perfect C programming, but I'm very fluent in C. I can do it really quickly. Assembly is something it would have been possible as well, but for me it's too long. And there's basic. I could have done it in basic, but my ignorance about the commands and everything, I'm not a seasoned user in super basic, so there was a learning curve attached to it. And I said, you know what the hell, C is really where I feel very comfortable, because that's the deal. I don't have a lot of time, so I want to make the life easy for myself, like everybody else actually. All right, so when this is done, you have installed CC65 the same way. You go in the variables, you're going to add the path so we can run this application. Of course, the next step is to fundamentally install it somewhere. So let's see, where's my DOS command? All right, so I have my DOS command here. So you see I've installed it in a different directory. I can also say that I have changed some names because I wanted to make it more meaningful to me, because example.com or it doesn't mean anything. So I had to rename things. But ultimately, when you're done, and there's one thing you need to do, because in part one, that's what we're going to do. I'm just going to, show you what you need to do to get going. So I would recommend Visual Studio because I think it's a great way to go about things. So like I said, I have install all the software, rename things. I will come back to this the next time we do a video about it. That's the part 2. But if you want to get going right now with the example, download, install it somewhere, get Visual Studio, I suppose. And I guess I'm using the command prompt. Sorry, I knocked off my camera. And oops, not too far. Okay, so there's one thing you need to do to not have an issue, which is that when you are in Visual Studio, I hope this is what you're saying. Yes, okay. So in the make file, so there's one make file called makefile, and the other one is makefile under PGZ. We'll come back to PGZ later. In the make file, there's the lib here. And I believe in the original file, and we could actually look into it just for fun. Let's go back to it. Let's see what I'm doing here. I'm not sure if I'm doing everything the way I should do it. Anyway, yes. So if I go into in the GitHub, in the example library, well, actually it's not a library, it's in the example code, and we look at the make file. So you see here in the F256, it's called F256Jr.lib. But in reality, if you go in the lib, it's called F256.lib. So you kind of need to change the naming here or there, but it's probably easier to just remove the junior here, right? So that's the thing, you will get an error if you don't change that. All right? So that being said, normally if you install make, you install CC65, and you create that, you change these little details, normally you should be able to do make. Now, since I changed the name, I haven't done anything to do anything. Make will say, hey, there's nothing to be done because my program is perfect. Okay, but normally, let's say if I make a change in the hold on, my monitor is freaking out. Where are you? Where are you? Okay, you're here. Okay, so if I do a change in my, for example, in my main.c here, So I put a lot of, because this is, like I said, an example that accesses the floppy drive, writes a file in the floppy drive. And so you could probably change that, put a 0 instead for the SD card. But let's say I'm going to put another put here just to create a change in the file. I'm just going to go back to DOS. There you go. And I do make. And then that's what happened. And then it's going to create, in my case, right now, the word for the output is called output.bin. All right. So I created a program, and if you go deeper in the different files, you'll see that the program has been located at the address 2000, which is a sweet spot to get things started. And normally, the next step would be to get, hold on. So normally, after you created this, what you can do, normally the best strategy is to get a RAM cartridge and to use the uploader that I have here. And what you would do normally is say, hey, whoops, I'm going to target the real thing. I'll have to get better at this. So you would say, okay, let's choose a COM, right? And then go look for the output.bin and say, hey, I want to put that in, for example, the address here for the cartridge, which I believe is 10. So this is the destination address, which would target the flash, the RAM cartridge directly, and you would send it in the application. So at this point, I don't have a RAM cartridge, so it's not going to work. Or what you could do is say, hey, I want to go put it in the flash somewhere. And right now there's a bug. We found a bug that normally you would find. There's like stuff in the block 10, 11, 12, 13 right now. So ultimately, if you can stick below 20, because for some reason 20 gets it to, the microkernels believe it's a cartridge, so it starts to run it before super basic and everything else, and so it goes into a loop and never comes out. So going below 20, so 1F is a good sector, so 1E, and you would go and store it, and by doing so, then you would have the software. I think I could try. Somebody sending me wave and say, why don't you try it? So I would click on the flash here. I'll get you to see the output. All right, so I'm going to, you know what? I feel that, no, you know what? I'm going to connect, and I'm going to send the binaries. And normally it's going to say, hey, program. And now it's not doing much. I don't know what it's doing. I don't know. It doesn't like the capture. What's going on? Oh, yes, I want to reflash. Okay, so there you go. There was a question. All right, so the application should start. All right, so normally the flash has been reprogrammed. I'm going to reset it. All right, so in the file, I think it's in the Visual Studio. I'm going to bring it back. I'm going to bring it back on top. Again, it's okay, so here somewhere, is it in the kernel? No, it's in the header. I called it header. So you see the word I use here, flash. That's the name. So normally, if I shut this down, if I go here, all right, so I say CLS. If I do flash, oops, oh, slash flash. So you see, cartridge, testing, get char, press C to exit. That's it. So I just programmed, it was registered, it's in the flash, the microkernel saw it, and I can execute it. So that means that from, after done all this, then you have like a system in place to actually do your code and get it to run. And that's, of course, part of my microkernel. So before I stop for this episode, I just want to show you the web browser, not the web browser, the Visual Studio. I want to bring it back. And essentially, with this example, you have the main that I call main because it was not called main. There's a bunch of test code to go read the SD card, and that's why I was so tempted to use that example, because if you look into the other code, let me see, where did I put this? There's a kernel.c. So the kernel.c is the interface that Gadget was so grateful to put in place. So she put a bunch of usable little routine that we can use. So scroll out, get in, you know, to go get a path. So that's basically the layer that talks to the FAT32 layer that was created by Michael Steele and somebody else. I don't remember his name. I am so sorry. Which is the main author. I think Michael came in later to change things, and that's the same block used in the X16. It's open source. So get in, you know, open. So right from the get-go, you have access to the device, the SD card, or the drive, which is very handy, and it's in C. So for me, it's going to be awesome because the only thing I need to do is create a small CLI, which is a CLI, which is the, you know, a small user interface, whatever. My God, my memory is... Anyway, and to put some command in place and to execute certain things. And since all the libraries to go and fetch the file are there, then, you know, I'm golden. So that should be done pretty quickly. And that's what I'm going to do and put it out there. And that will allow people to create their application, put it in the cartridge. So if anything comes in the future and we want to put some games and stuff like this and distribute it, then people can reflash their cartridge. And again, Bob's your uncle. So there's probably a lot of Bobs out there. So that's it, guys. So that's episode 1. I'll come back later with a more in-depth of what I'm going to do for the application itself, how we go about flashing. But to get started, I think it's going to be great. So I hope you enjoyed that very technical, but probably very useful. Very useful. Let me find the picture I wanted to studio. No, that's not what I want. Well, I don't know why I don't see it anymore. Oh, I'm gonna reset it again. Visual Studio, no. Web, no. DOS command, no. I don't know why my capture doesn't work anymore. Oh well. Oh, there you go. Alright guys, thank you so much, and I will see you soon. There's no fade in this one because I'm in studio mode. Alright.